8-5, factoring x squared plus bx plus c. So our objective is to factor trinomials of the form ax squared plus bx plus c. And we can write some of these trinomials of the form ax squared plus bx plus c as the product of two binomials. So this is going to be one of the more important sections that we're going to cover and one of the more useful skills that you'll use in later math classes, and that is factoring a quadratic trinomial. Okay, so to understand how to do it, first we remember how to multiply x plus 3 times x plus 7 with the FOIL method, right? First, outside, inside, last. So the first two, x gives me x squared. X times 7 gives me 7x. 3 times x gives me 3x, so it's 7 plus 3 times x. And then 3 times 7 gives me the 21. 3 times 7. So we can clearly see that the last terms, the 3 and the 7, multiply together to give you this term right there in the trinomial. The first terms, x and x, multiply together to give you that term right there in the trinomial. And this middle term, this 10, comes from the 7x and the 3x's added together. So the coefficient of the trinomial's x squared term is 1. The coefficient of the trinomial's x term is 10, and the sum of the numbers of 3 and 7 in the binomials, right? We just said that. And the trinomial's constant term, 21, is the product of the same numbers, 3 and 7. So we have a sum and a product of these two numbers, 3 and 7. To factor a trinomial of the form x squared plus bx plus c as the product of binomials, you must find two numbers that have a sum of b and a product of c. Okay. So, what is the factored form of x squared plus 8x plus 15? So, we want two numbers that have a product of 15 and a sum of 8. To figure this out, the easiest thing to do is to, well, there's an infinite amount of numbers that have a sum of 8, but let's focus on this number right here, 15. Let's find all the numbers that have a product of 15. Well, that's going to be 1 and 15. Okay. It's also going to be 3 and 5. Okay. Now, 1 and 15, when I add them together, I get 16. But 3 plus 5, when I add them together, that gives me 8. Okay. So, to factor x squared plus 8x plus 15 as a set of two binomials, the first two numbers, or the first two terms, are going to multiply together to give me x squared. Okay. Now, this section is called factoring x squared plus bx plus c. So in this case, we're not going to put a number in the front yet until next section. Okay. But for now, let's keep it a little bit easier and just focus when these two things are just going to be x, because x times x is x squared. Now, plus 3, plus 5. Let's check this. X squared plus 5x plus 3x plus 15. And the 5x and the 3x combine to give me 8x. Okay, so the way I want to do this is find the factors of c that add to b. Okay? And we'll get into a little bit about how these two signs can give me clues. Okay, this sign right there means that the two signs have to be the same because a positive times a positive has to give me a positive, right? We're multiplying the 3 and the 5 here in order to get this 15. And this sign right here means that both signs are going to be positive. And we'll look at some other examples in the next section, or in the next problem. Okay, so first, factor this. So I want the factors of 24 that add to 11. So to figure out the factors of 24, that's going to be 1 and 24. If I add those together, I get 25. No good. Okay. Next is 2 times 12. When I add those together, I get 14. No good. 3 is a factor of 24. 3 and 8. And when I add those together, I get 11, which is good. Okay. So my answer is going to be two things that multiply together to give me r squared. That's r, and then plus 3 and plus 11 and plus 8 to give me my 11, and those are my two binomials. This is now factored. And of course, check it to be sure by FOILing it back out. Okay. Some factorable trinomials have negative coefficients of x and positive constant terms. In this case, you'll need to inspect the negative factors of c to find the factors of the trinomial. So, in this case, I want two numbers that multiply together to give me 24. Both signs of these numbers, both signs of these numbers are going to be the same because 24 is positive. And the only way to get a positive 24 is to multiply two numbers together that are both positive or both negative. Negative 1 times negative 24 is positive 24. So this sign tells me that both of my signs are the same. This one tells me that they are both negative. So if this second sign is positive, I know that both of my terms in my two binomials are either going to be both positive or both negative, and the middle term tells me what they're going to be. Well, so put them together. Negative 1 and negative 24, that's negative 25. No good. Negative 2, negative 12. We just did 24 before. Add together, and we get negative 14. No good. We had 3 and 8. Put those together, we get negative 11, and that is good. And now I can make my binomials. I don't have to keep going. If I find the factors that already work, yeah, I could put 4 and 6. But I already know that 3 and 8 are going to work. Okay, so this is going to be x minus 3, x minus 8. Okay, let's try got a problem. What is the factored form of y squared minus 6y plus 8? Factors of 8, negative 1, negative 8. That multiply together to give me 8. When I add them up, I get negative 9. No good. Negative 2 and negative 4 is negative 6, which is good. So I'm going to have y, right? Make sure you keep the same variable. Y minus 2, y minus 4. Okay. Can we factor x squared minus x plus 2? Factors of 2, there's only 2 is prime. That's all we got. Negative 1 and negative 2. When I add those together, I get negative 3. So this does not, this trinomial right there does not factor. And they don't all always have to. Okay. So it's possible for a trinomial not to factor. We can solve it, but that's something for later. Okay, so when you factor trinomials with a negative constant term, you need to inspect the pairs of positive and negative factors of C. So what does that mean? That means when this term is a negative, it means that one of the two factors is going to be negative. Okay, and this one tells me that the bigger one of those terms is going to be positive, but we can look at that again in a little bit. Let's look at the factors of 15. So negative 1 times a positive 15 is equal to 14. That is not 2. But I also have to check positive 1 and negative 15 because when I multiply these two together, I also get my last term, my negative 15. So when I do this and add these two together, I get a negative 14. Also No good. Okay, let's try 3 and negative 5. When I multiply these two together, I get a negative 15. And when I combine them, I get a negative 2. But I want a positive 2. And so negative 3 and positive 5 combine to give me 2. Now, when we have a situation like this, okay, and I see a negative in the second sign, I know the two signs are different. Again, this second term there tells you that the bigger number must be positive. So I didn't even really need to check these two because I know they're not going to work. Okay, I can focus on my bigger number being positive and my smaller number being negative when I combine these two terms. Factored form, let's write this out. Variable is x. So we have x minus 3, x plus 5. Let's try got a problem. Ooh, 2. Okay, so factors of 36. Both signs are different. The bigger factor is positive. So the factors of 36 are 1 and 36. One of them has to be negative, and I'm always going to make the smaller one negative in this case. When I put those together, I get 35. No good. Okay. 2, negative 2 times 18 is 16. No good. 3. So negative 3 and 12 combine to give me negative 36. And that is positive 9. Okay. So my answer is n, same variables here, n minus 3 times n plus 12. Okay. Let's check this one. Now, factors of 21 that combine to give me a negative 4. That means the bigger number is going to be negative. This means that the two signs are different. This one means the bigger one is negative. So we go like this. And basically, I can eliminate half my choices by realizing this and not have to check both 1 and negative 21 and also positive 21 and negative 1. Combining these gives me negative 20. Not what I'm looking for. 2 does not go into 21. 3 and negative 7 multiply together to give you negative 21. 3 minus 7 is negative 4, which is what I'm looking for. So we have c plus 3, because this one's positive, c minus 7. Okay? All right, so we can put these into word problems. It doesn't change our strategy at all. Area of a rectangle is given by the trinomial x squared minus 2x plus 35. What are the possible dimensions of the rectangle? Use factoring. Well, to find the area of the rectangle, area is going to be equal to the length times the width. Okay, so I want two binomials that multiply together to give you this trinomial. I know the signs are going to be different. I know the bigger one is going to be negative. The bigger term is going to be negative. And I'm looking for two numbers that multiply to 35, or sorry, multiply to negative 35 and add up to negative 2. So, we can even do this if I want to, make sure I remember that it has to be negative. Bigger number has to be negative, so let's try these first. 1 and negative 35 combine to be negative 34. Nope. 2 does not go into 35. Neither does 3. But 5 does. And that's 5 times 7. So 5 and negative 7 give me negative 35. And when I combine them, I get negative 2. Two numbers that multiply together to give me negative 5. And when I add them, I get negative 2. So my answer looks like two sets of parentheses, x plus 5, x minus 7. Okay? No real big problem with a word problem in this case. Got a problem? factors of a rectangle's area, again, is x squared minus x minus 72. Area equals the length times the width again. Okay, so we're looking at the factors of negative 72 that add up to 1. Both signs are different. Bigger number is negative. 1 and negative 72. When I put those together, I get a negative 71. No good. Let's just go down the list. 2 and negative 36 is a negative 34. 72 it is divisible by 3, so 3 times negative 24, and that's negative 21. No good, no good. Is 72 divisible by 4? Yes, it's 4 times 18, and that again is negative 14, which is no good. These numbers, in order to work, right, in order to add up to negative 1, they're going to have to be kind of close together. I do kind of see it. Let's just skip to the end here. And it is 8 times negative 9 is a negative 72. When I add them together, I get a negative 1, which is what I want. Okay. If you see the factors, that's great. If you need to list them all here and go step by step through all of them, I skipped over a couple, but whatever is going to help you get the answer. And of course, my answer is x plus 8, right? The 8's positive, x minus 9 in my factored form. Okay. We can also factor some trinomials that have more than one variable. Consider this product, p plus 9q times p plus 7q. So here, the p's multiply, and now here, we have pq, okay? And then in the last term, we have the q's. So look, we have squared, both of them multiply together, and then the other variable squared. So this suggests that a trinomial with two variables may also be factorable if the first term includes the square of one variable, squared. The middle terms include both variables, one of each. And the last term includes the square of the other variable. Okay. Can I factor this? X squared, square, xy, one of each, y squared. So yes, I can. All right. And now when I do factor this, I'm going to use the same method, except that when I write my answer, the first terms are going to have an x, the second terms are going to have a y. Okay? But now we need the numbers. So we need the factors of negative 55 that multiply, the two numbers that multiply to 55, and when I put them together, I get a positive 6, which means it means the bigger number is positive. So when I put those together, right, I get a negative 50, or I get a positive 54, not good. And let's just go right to negative 5 times a positive 11 is a negative 55. Negative 5 plus a positive 11 is a positive 6. So I'm going to go x minus 5y, x plus 11y to be my answer. One got a problem. Perfect square, square, one of each. So I can factor this. I want to find the factors of negative 27 that combine to give me 6. The signs are different. The bigger number is positive. So negative 1 times a positive 27 is negative 27. When I add them together, I get a 26. Oh, good. Negative 3 times 9 is 27, and when I add them together, I get a positive 6, and that's what I want. My variables are m and n, so, whoops, yeah, m minus 3n, and m plus 9n. Okay, so we should have gotten pretty good at these techniques now. Okay, factors of 12 that add up to 7, 3 and 4. So it's x plus 3, x plus 4. Factors of 42 that add up to negative 13. That is going to be, yeah, 7 and 6. So x factors of 42 that add up to negative 13. So it's x minus 7, x minus 6. The factors of 40 that, and now the way I like to read this one is factors of 42 that add to negative 13. Factors of 40 that subtract and give you 3. So obviously these two numbers are going to be different signs. And I want a positive 3, so that means the bigger number is going to be positive. And it's going to be, oh, whoops, I made a mistake in the previous one here. Not x, r. Just like this one is going to be p plus 8, p minus 5. And then finally, this one is going to have an a in the front. It's going to have a b in the back. Now we just need to find the factors of 32 that add up to 12. 8 and 4. Plus 8b plus 4b. Same for the word problem here. The factors of 28, that when you subtract them, you get a negative 3. Or when you add a positive and negative together, you get a negative 3. So that's going to be x, the bigger number, so n. The bigger number is going to be negative n minus 7, n plus 4. Tell whether the sum of the factors of the constant term should be positive or negative when you factor the trinomial. Well, the sum of the factors here should be positive, positive, and negative when I factor the trinomial. Depends on what the middle term is. Under what circumstances should you look at pairs of negative factors of the constant term when factoring the trinomial? Only look at negative factors if the first term is negative. That will sort of guide you as you go through this factor. And that was 8-5, factoring x squared plus bx plus c.